Hey everyone, welcome to another problem session. So today we're going to do a two-part problem based on same paragraphs description. This problem comes to us from Indian JEE 2024. So this is a 2024 or 2024 JEE Advanced Physics Paper 2. Okay, let's read this problem carefully. So we have these two balls which are attached to a spring, and they're making particles with the center masses at x0. This is the cm. Are oscillating with amplitude a, and so this is x coordinate, and this x1 at time t. So this is situation at time t, and this x2 at time t. We don't have to worry about this. This gonna ball will come and hit, and then that will be the end of the story for that. From the look of it, the D, this side, and so 2D is the 2D is length of the spring when like relaxed, and this is the amount that's stretching back and forth for this guy, and this amount is stretching back and forth for that guy. So if you look at stretch at any time, there will be x1 minus x2 minus 2d. So that will be the stretch from the way this described. Okay, so you can see that if you just do this, just trying to understand this right now, so you will have a 2d cancel out, and it's going to be 2a sine omega t, and depending on time, that depends on how much is the stretch of the spring. Okay, particle 3 is just moving at this constant velocity, and it's going to strike it at some time t0. So for question 16, t0 is 0, but question 17, t0 is pi over 2 omega. So there are actually two different problems. Because the ball hits this ball at two different times, but because they're related, I'm going to do it in the same sitting. Okay. Then finally particle want to acquire a center of mass VCM. So this is before and after the collision. Before this, because oscillation time dependent, this may be, say, moving. It may have its own velocity. It may have its own velocity. Okay, or it may be pointed that way, pointed that way. So depending on instance you pick, the velocity may be pointed different time, different directions, and may have different magnitude. So the Cm of this system has velocity VCM, and this is supposed to be after the collision. Okay, so here the VCM is after the collision, so this should be after. Now the question is, what is the value of this? Now, it's supposed to be elastic collision. So we need to figure out just collision between these two guys at instant t equal to 0. All right, so now we just have a before. So this is number 3 and number 2. What's the velocity? This guy's u0, and I have to figure out its velocity. Well, I have to look at x2, and so x2 is some constant minus a sine omega t. So this I'm calling this a constant. Let's call it c2. And dx2 over dt will be x velocity, and I get minus a omega cosine omega t, and at t equal to 0 this will be minus a omega. So actually x is pointed that direction and the magnitude a omega. So this is this situation before, and then you have a after situation. We can say it recoils u prime that way, and maybe v prime that way, v2 prime that way. At this instant, let's look at what x1 velocity is, c1 plus a omega sine omega t. So although I don't need for this, but later on might need it, dx1 dt is going to be a omega cosine omega t, and t equal to 0, and that just gives me a omega. So, and so let's call it 0 minus time, and this is 0 plus time, and if I wanted to do 1 also, I'll put it here, but I don't need to right now. So how do you figure this out? Well, momentum conservation and kinetic energy conservation, and then you solve it. Okay, so momentum conservation will give you u naught minus a omega equals to v2 prime minus u prime. So you get one equation. Mass is the same, so I don't have to put everything has same mass in this problem, so I don't need to put, and so half m will be same in everything in kinetic energy conservation. So just have to do u naught square plus a square omega square equals to v2 prime square plus u prime square. And the question is trying to find VCM of that this system. So I just need to figure out, I don't need to worry about the velocity of the u prime. So u prime can be solved and plugged in here. Let me clean up, jump over there. So you have a u prime equals to v2 prime, and u0 is supposed to be given over here, a omega over 2. A omega over 2. So this thing is minus a omega over 2. Minus a omega over 2. If I plug in there, this, and this becomes plus m this. Now put in here, this is a omega 2 square plus a square omega square, v2 prime square plus v2 prime plus a omega over 2 square. So just to expand this, so this is 5/4 a square omega square over here. And 2v2 prime square plus a omega v2 prime, no, this is not square over here, the square is over there, plus a omega a square inverse square of 4. So 1/4 goes away, so just leaves the whole thing. Bring it over that side. It's 2v2 prime square plus a omega v2 prime minus a square omega square equal to 0. So v2 prime equals to 1 over 2 times 2 minus a omega square root of a omega square plus 4 times this times that. So 8 a square omega square. Nicely, this thing comes 9 a square omega square. So this whole thing becomes a 3a omega. So pull a omega out, 4 minus 1 plus or minus 3. So you can see that with a plus sign, I get a omega over 2, and with a minus sign, plus here gives me that, minus here gives me that, minus just a omega. So this is just as if this particle just doesn't even see it, the no collision. This is so whenever you do elastic collision, there will be solutions like that. If you have equal mass, you're definitely going to get that solution like that. So this is going to be a omega over 2. That's the answer. So we got a v2 prime equals to a omega over 2, and v1 prime is same as v1 before. So this is 0 minus, and this is 0 plus for the time, and that's was a omega. So now from this we get the Cm. So VCm 0 plus is going to be just a 1 over 2 2m m a omega over 2 plus m a omega. So m cancels out, and this is 3/2, so this is 3/4 a omega. So this divide by a omega over here, so VCm over a omega is 3/4. So this is 0.75. So that's the answer. Now we can do this next. Okay, so I'm going to pause and erase and do the problem 17. Okay, so this problem is about finding out what happens to this ratio when time is this. The B is what happens after collision is they, if you're in this frame, it hits. In this case, you'll find that it gets a center mass. The whole thing moves, and then this oscillates. And this oscillation amplitude is B. So this is for t greater than t0. T before t0, this oscillation was A, and this oscillation was A. So this is the case, and we have to find the relationship between A and B. Okay. All right. And because this all is squared, etc., it's a kind of hint that energy conservation is kind of will play some role here, because in a spring you have a this is how much spring is bit deformed. See, in this particular case, when that's oscillating, it's like a 2b. When that's oscillating, deformation of the spring is 2b and is 2a. So in addition to kinetic energy consideration, here potential energy will be half k 2b square, and here potential energy will be half k 2a square. But k is not given here. So instead, they've given the angular frequency. So, but we can find the relationship between them by the following means. Okay, so if I knew k, I would be able to use energy. We'll figure out what's the energy at t0 plus. So this t0, but instead of doing that, we can say t equals to t0 plus just after the collision. So we figure out the situation like what that is. So at t0 plus, we can find energy at t0 plus equals energy at t greater than t0 at any other moment. And when I equate this, we will be able to hopefully find the answer. Okay, but in the hurdle is, okay, kinetic energy is fine, we can just have mass and velocity is squared or speed is squared, but where do we get a k? So to get the k, we will either you already know, so actually k over mu is going to be omega squared. Either you may know this formula for this kind of system. If not, you have forgotten, then it's a very quick way to figure out. So this is, say, x, x1, x2, this is m, and this is m. So m1, m2. On both values m, this is m1 and this is m2. So let's see, the dot is d over dt for me, okay? So m1 x1 double dot equals to minus k. Deformation will be x1 minus x2. So the minus, 2d, right? That's deformation. m2 x2 double dots will go just opposite of that. Force will apply on the other one. So minus k x1 minus x2 minus 2d. So now let's look at m1 x1 minus x2, difference of this double dot is going to be minus 2k, this thing x1 minus x2 minus 2d. Well, of course you can say y equals to x1 minus x2 minus 2d, then to give me this m1 and m2 are same, so this is going to be m1 plus m2. So this is m, not m1 plus m2. This is going to be both m, so m is common. So we have m y double dot equals to minus 2ky, and so this tells you it's a simple harmonic motion, and so divide by m. So this quantity here is omega square, so omega square equals to 2k over m. So k equals to m over 2 omega square. M over 2 mu is m1 m2 over m1 plus m2. So in this case, m square over 2m is m over 2. So that's where this formula comes from. Let me pause and erase this thing, but this is the side thing that if you have forgotten, you can figure it out in this part. So in our strategy for this, the only thing to figure out what happens at T0 plus. So T0 plus is T0 is when the collision is. T equal to T0 is collision. Now, again, 3 is going with U0. This time, the time is pi over 2 omega. It's really nicely given, pi over 2 omega. So pi over 2 omega. So if I look at this velocity formula, so this is number 2. What's this velocity? Well, v2 for pi omega t0 will become omega times pi over 2 omega will come pi over 2, and cosine pi over 2 is going to be 0. So this v2 equal to 0. So this is t less than t0 situation. So this is mass m and this is mass m, and it's going to collide elastically. So this will t equals to t0 plus. Right after collision, this guy will come to rest. v3 will be 0, and v2 will be equal to this guy u0, which is a omega over 2. So this is the situation. We also need for the kinetic energy. We also for the kinetic energy for t greater than 0, or this situation t0 plus. We also need to know how far whether this is moving. For the same reason, v1 is also 0. Okay, so v1 is also 0 for t equal to 0 t0 minus and t equal to t0 plus, because this guy is not participating in collision, so its speed immediately doesn't change. So in this situation, we know that this guy is v equal to 0. For this situation, we know equals 0, but this guy has v equals to a omega over 2, which is moving that way. This is at rest. It is stretched by 2a. So this is the situation here. As a result, center of mass will move, right? I personally like to go over the center mass frame here, because then I'll just look at the oscillation part. I don't have to worry about the center of mass motion part. Okay, so let me erase and kind of come back. So I got some more space here, so I can draw. So T0 plus, this is the situation. I just because this got cluttered here, I just want a clean drawing. So this is the how much the spring is deformed by or stretched by at this time. And if you look at the CM, CM is going that way at a omega over 2. So if I jump to the CM frame, so I'm going to do the calculation, calculate in CM frame. That makes much easier actually. So in this frame, the CM will go nowhere. VCM is 0 in this CM frame, and this guy will just go back and forth. But the velocity, instead of this, it will be that minus that. So a omega over 2 minus a omega over 4. And this minus that will be 0 minus a omega over 4 for this guy. So this actually going this way and this going this way with same velocity. So a omega over 4 and minus a omega over 4. And the stretch here is delta is 2a. So we can figure out the energy in the CM frame very easily. And that will be energy at T0 plus will simply be half kinetic energy with this and the same mass and same speed. So 2 times mass a omega over 4 square plus half k. K is half m omega square. Half m omega square for k and 2a square. So this is not total at T0 plus time. Okay. Now at another time we're gonna pick where this thing is fully stretched. So this is now stretched will be 2b and this has come to rest. V equals 0 and V equals 0. At some time it will be fully stretched and then thereafter it kind of moves down. So at that point it has just at this instant is going to be half times half m omega square times 2b square. Now, so these two equations must be equal because between this time and this time there are no external forces acting and it's energy is conserved between these two times. So we just equate these two and solve it and see if this what the value of this will be. Okay, so let me clean this area and then I'll be back.